Hi, chat. How's it going?
A very good morning, everyone. How's everyone doing? Oh, we should put a little live tweet.
Yeah, tweet out. Yeah, my
I
partner
shall.
is ill today, unfortunately, because she got the booster for COVID, so ill for good reasons. I'm gonna get mine next week.
How you feeling? Excited?
Yeah, although it's like 9 a.m. on a Saturday, and the only place I could get a booking is like miles away from my house, so I need to either uh, cycle all the way there, or I don't know, maybe get a cab or something.
Yeah.
Hey Walter, how's it going?
Like actual. I feel like after getting a booster shot, not having to like do a bunch of physical exercise tends to be a good idea.
Yeah, I mean, for my first two shots, I cycled there and back, and but it wasn't too far. It was just in the city center, whereas this is like out of town. I would need to go.
All right.
But we'll make it work. Anyway, shall we?
I guess.
Sorry, go ahead.
Oh no, I was gonna say something.
Make some
Banter. But yes.
Always.
Let's jump in.
Hey Ross, how's it going? Alright, smoke basin. These caves seem to be lava tubes. What is a lava tube? A lava tube is a natural conduit formed by flowing lava from a volcanic vent. There we go. Got all these nice lava tubes. Beautiful.
I wanted to say they're the more dangerous counterpart to the fish tube.
The fish tube.
Yes.
People in chat have never
2019
seen
memes.
Yeah, 2019 memes. It was like just this tube, but how far did the fish tube stretch? Like
Incredibly long, like from like one lake to another or something.
yeah, in order to transport fish, and it was just literally this tube, like just thick enough for fish to go through, and the fish would just go through this tube. Amazing.
Yes.
Alright, so these caves seem to be fish tubes. Parts are still volcanically active. Small hydrothermal vents release fish into the caves that slowly settle like rain. If you can model how the fish flow through the caves, you might be able to avoid them and be much safer. Submarine generates a height map of the floor of the nearby caves. Fish flow to the lowest point of the area they're in. For example, considering the following height map, bunch O numbers. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest. First goal is to find the low points, locations that are lower than any of their adjacent locations. So most locations have 4 adjacent directions, up, down, left, and right, so we do not count diagonals. Locations on the edge have 3 or 2 adjacent locations, so this one has 3, this one has 2. In the above example, there are 4 low points, all highlighted. There's 1 because it's lower than 2, 9, and 9. There's 0 because it's lower than 1 and 1. And this 5 and this 5. All of the locations on the height map have some lower adjacent location, and so are not low points. The risk level of a low point is 1 plus its height. In the above example, the risk levels of low point are 2, 1, 6, and 6 because they're 1, 0, 5, and 5. Sum of the risk of the low points is 15. Find all the low points on your height map. What is the sum of the risk points? Okay, that makes sense. So we just essentially want to loop through all of... I'm sure there's probably some smarter ways to do this with some, I don't know, like gradient descent type things. But the simple, naive way to do it is just loop through all of them, check the adjacent locations, check if it's lower than all of them, and if so, then that's a low point. That's it.
Yes. Sounds about right.
Alright. Ready to get started?
Yep. Good luck and see you in a bit.
Yeah. Okay. Yosh is gone. So we want to parse this input. Now, one thing about all of these kinds of puzzles where you're having to check adjacent locations. At the edges, you need to check to make sure that you're not going off the edge of the map. But what you can do instead of doing that, instead of doing the check all the time, is just introduce another a halo, essentially, around all of the input, so that you don't have to do those checks. So I think I'll do that, just for simplicity. So in this case, we'd put a halo of 9s around the border, because 9 is the highest value. So what we'll do is we'll make we'll just do that with a vector of vectors, because why not? Let's just make these shorts. I mean, like I said, a vector of vector is not the best data structure for this, but it's just easy to work with. Call this map, and we'll loop through the input. So TL get lines of our input. For each line of the input, we're going to let's hash include vector. We're gonna make a vector of shorts. We'll just call L, and this is gonna start off with a 9, and then for each character in the line, we're going to do L.push back character minus the value of the character 0, which will give us it as a short, and then L.push back 9. Then we'll do map.push back, let's move L. Then we'll just insert another line of 9s into the to the start and the back. So set vector of shorts. L is going to be a number of 9s equal to map 0.size 9, and then map.insert at the beginning L, and then map.push back instead move of L. Am I staying in C++ for all of AOC? Yes, I am. Okay, so that should parse our map. So we'll just stick this in its own little function. Map equals parse map of our input. Helps if I can spell. Okay, so that should be our map. And now we want to loop through all the coordinates inside the halo and filter them for which ones are lower than all their adjacent ones. So I could use, I think I can use Cartesian product and iota for this. Let's see if I can get this right. I think I can do take the TL views Cartesian product of state views iota from 1 up until the is this a square? Can't remember. Anyway, from 1 up until the map.size. Thanks to follow Birkindink, however you pronounce that. Cartesian product of views iota from 1 up until the map.size minus 1. And then the same from map 0.size -1. Okay, this will give me all of the coordinates I want, and then I can filter that. Std views filter. So this should give me, does it give me a pair? Yes. So this will be a coordinate, and I'm gonna return, I want to filter so that I only have the ones where map c dot first -1, c dot second -1 is less than, no, it's greater than map c dot first, c dot second, and we could make this a bit neater if we wanted to, but this will work for now. +1 and there. Okay, that should filter our coordinates. Yeah, I could do auto x, y equals c, and then replace c dot first with x, and replace c dot second with y. Thank you. Okay. Then that should give us the coordinates of our low points, and then we want to sum up the what did they call them? The risk factors, where the risk factor is just std views transform takes a given coordinate, returns map c dot first, c dot second +1. So that is going to be our low point risks, and then we're going to output std accumulate of this is probably not going to be something I can std accumulate because it'll not be a common range. I can do TL fold low point risks starting with 0 std plus fold.hpp. Thanks to the follow dead frames. Okay, let's give that a shot. I'm checking diagonals. I'm doing y -1, so that should be oh yes, sorry, thanks. Like I said, you can always fail at basic maths on stream. There we go. Cannot find fold.hpp because I used the wrong quotes. Okay. What's going on here? Get lines is not a member of TL. TL views. Line 28. Oh, is this a mismatch in signedness? Yeah, this will be fine. Probably should have done it the other way around, but might do. Map cannot be implicitly captured. Missing a parenthesis. Yay. Okay. Debug assertion failed. I got out of bounds. Oh, parse map failed. What's going on here? I don't know why this is sticking around either. Map is... Oh, shit, I forgot to paste in the input. Just like yesterday. Helps to actually... There we go, 15. Was that the right answer? Yes. Okay. Let's run this. 458. That seems small, but we did it. Yay. Alright, let's tell Yosh. Alright, Yosh, we're done part 1.
Hey, we're still working on a loop.
Alright, cool.
Yeah, I don't feel like we're far off.
I did a kind of... The code looks kind of horrible, but I did it all with just range views. I didn't put any loops in.
Oh no. But it's functional side, that's great.
Yeah, it's kind of hard to read though. Especially because the auto formatter is like, what on earth are you doing? Alright, I'll let you carry on. We'll move on to the second part.
Yes. What type of thing's the second part?
Alright, why don't I read the second
Even though
part?
I can't read.
Right. Next, we need to find
Sounds
the
good.
largest basins so we know what areas are most important to avoid. A basin is all locations that eventually flow downwards to a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being in any basin, and all other locations will always be part of exactly one basin. The size of a basin is the number of locations within the basin, including the low point. The size above has 4 basins. Okay, so it's all areas contained within 9s, essentially. It's flood filling.
Interesting. Yeah, I like pre-stream. I was like telling Sly like of exactly my 2 computer science classes that I ever like took. We had like one on heuristics, and we covered an algorithm called simulated annealing, which is to find like local maxima and minima, like in a like search. And this gives like strong vibes for that. Like find the basin is like find the minima essentially.
Well, the basins are this is literally a flood fill algorithm.
Oh, hey. I've never heard of those.
It's basically the kind of algorithm that you would use for like if you're in MS Paint and you draw a bunch of lines and then you use the bucket tool.
Oh.
Yeah. So you can,
Hell yeah.
there's a few different ways you can do it, but like the simple, well, one simple-ish way is just to do it recursively. Um, so you start
I
off
see.
on you start off at the low point, and then you um so you have one additional piece of state for each location, and that's whether you have checked it yet or not. And then you start off at the low point, and you call flood fill on. You set that to filled, and then you call flood fill on every adjacent location, and then you recurse
Oh, I see.
Until you're until all of your
Oh.
adjacent locations have been touched or should not be touched.
So essentially, you spiral outward. So first pass, like from your low point, you like spiral outward once for every like low point, and then you do second one, which is spiral again from like those low points, like out one more. Is that right?
Pretty much, yeah.
Yeah. Oh, cool. I think I've seen this like graphics programmer friends be like implement stuff like this, and I see like like fill up like that.
Yeah.
But I've never like done that. So yeah, okay, cool. That's super exciting.
All right.
I'm excited for this one.
Yeah. All right. Gonna
Cool.
make myself
Good luck.
look. Get rid of Yosh. Okay. So we want to find all of the basins, and multiply their sizes to get there. Blobson's saying this problem can be solved in linear time, linear to the number of locations in the map. Yeah, probably. I'm just gonna do a recursive flood fill because it's relatively simple. Okay, so let's just do the same thing here, because we're gonna get all of the low points, and then from each low point we're gonna flood fill it. And let's, instead of storing a vector of shorts, we're gonna store could just store pair, but I'll give these nice names. Call it location, short, height, and bill filled. So this will be vector of locations, and whoops, make sure all of these 9s are locations. We could have had a side vector or something instead, rather than storing this in the same place, but whatever. This is gonna be dot height, and these will all be dot height. It's off by 1, this one. Okay. And I'll just copy paste this over here as well. Alright, we're not going to do this step. Are we? No, because we just want the low points. Alright, that's the low points, and then for each point in our low points, we'll get we'll destructure that. For each point in our low points, we're gonna flood fill map XY. And flood fill is going to take our map type, which is a vector of locations. Map. And it's going to take our X. Or actually, this wasn't a size t, this is a signed size. What does signed size in return? I can't remember. Pointer div t. Should really be a unsigned, but I'm just gonna get this to work. Okay, so we're gonna flood fill at map with pointer div x. So I think we do map x y dot filled equals true. And okay, so we're going to, we need to get the size of the basin, so let's just keep track of this. And filled equals 0. So we're gonna fill ourselves, and then for each of these points, so we're gonna, if that is not filled, then we're going to flood fill map x minus 1 y and filled. I think I'm not processing the filled properly, but let's just think about this for a sec. I guess we can not pass this down and just return this and accumulate it each time. And filled plus equals flood fill that. And we could do this check at the start so that we don't have to do this check for inside all of these if statements. So if map xy dot filled, if we're already filled, then return 0. Otherwise, fill ourselves, then flood fill x minus 1, flood fill x plus 1, oops, flood fill y plus 1, flood fill y minus 1. Sure. And then we want to accumulate all of those by multiplying them, so we can just do low points piped to std views transform. This will give us coordinate, flood fill map with c dot first and c dot second. Return, make sure we capture map. basin sizes. Okay, that should be all of our basin sizes, and then we can do std cout tl fold basin sizes, starting off at 1 and using std multiplies. Give that a shot. Can we see Marshmallow on stream? I don't have Marshmallow right here. I do have Lexical Cat. She is very soft, aren't you? You want to say hi? Meow. Okay, you don't want picked up right now. That's okay. You can get down. No, you want to be on my lap. You just don't want me to pick you up. That's fine. We forgot to initialize and filled. Equals 0. If Marshmallow stops by, I will make sure he comes and says hi. Hey, thanks to the follow. Ali Reza, honey. Oh, we had a debug assertion failure. Oh, we didn't check on on if we should actually do a flood fill on a position, which is if it's 9. If it's already filled or map x dot height equals 9, then we don't fill it. Oh, and this should start off at 1. Zero. I'm not sure if I saved that in time. Let's try this again. Zero. Okay, well that's wrong. Okay, what's going on here? Stick breakpoint. Okay, so we are starting at 0, 31, setting in filled to 1, so we should be at least returning 1. Is there something wrong with my fold? Let's stick this in a vector for now. TL2 std vector, just so I can stick a breakpoint here and see what basin sizes we get. Oh, you only want the 3 biggest basins. That's fine. I mean, we have a bigger problem than that so far. Don't know if TL2 yet. Yeah, there we go. Oh, a lot of 0 basins, right, and then I multiply by 0, and that, yeah. Well, no, because I started all the low points, so I shouldn't, oh, I'm probably counting some basins multiple times, though. Anyway, let's see where we get to. Here are... What is this? I can't see because of this weird pop-up. Our basin sizes. Okay. Let's, yeah, you said it was the 3 largest basins? Find the 3 largest basins and multiply their sizes, okay. So we can just do, take basin sizes, do std ranges, sort basin sizes, and then do a TL fold on basin sizes, std views, take 3. Hey, Razzle time. Let's try scan. Okay, so our basin sizes, we sorted them in the wrong order. Stood. Yeah, like we could use like stood nth element or something like that 3 times. Is there? There's a stood partial sort, right? Yes. Let's do that. Let's do it at least somewhat properly. Stood ranges, partial sort. Sort basin sizes, middle big basin sizes, dot begin +3, and we want to use stood greater. Is that the name of the stood ranges greater? Yes. So that should put the 3 highest ones at the front. Looks good to me. And then we output big number. Yay, we did it. Hey Ash, we're done.
Hey, Sai. We are not. We're still on the first one.
Cool. You want to do
Live share.
Live share.
Yes. I am finding a link.
All right. So far we've been, if we need to share each other's screen, we've just been sharing on Zoom. But this time we're gonna try doing live share, which is a Visual Studio and Visual Studio Code feature. So Yash is currently sending me a link, which I should be able to paste in to join. Yes. Maybe I should hide it on my stream so that random people don't join. Just 1 second.
Hold on, getting 20 people to join my Visual Studio session.
Okay, right. I should be joining Yosh now. Okay, I can see your code. Okay, so let's have a look at Yosh's code. Yosh, you can see Yosh here. Yosh can see me. Hi.
Yes. Hi.
I can edit Yosh's code.
Oh, stop it.
So what what's going wrong with your code?
We're getting out of bounds errors. So Rusk in chat shared some really good insight of like, hey, the easy way to do this is to like add essentially like a wall around it.
Yeah.
That's clever. I mean, I didn't go that route. I'm like being a little bit stubborn right now. So
you're looping for Y and X. You're checking the Y is not the top line, and
yes.
Are you sure that these coordinates are the right way around? Are you positive?
Well, no, we're getting out of bounds errors, so the coordinates are off. We know that much. Yes. Yes, exactly. Right. So something's going off, and we're trying to debug what it is. So right now on line 29, well, 30 now, we're getting an out of bounds where our y is too big. Oh, I think I found it.
Yeah.
There.
Yep.
There. Okay, let's try that once more. I also changed one offset somewhere. Attempted to subtract with overflow. I think did that work? Okay, let's run this once more. Okay, that makes sense. So 34 x minus 1. If we're not on C left, so C left is 0, then we want to be able to subtract from x, where x is the x coordinate. Wait. Oh, and hold on. There. We just had to like inverse like our whole logic for this to work. Okay, getting closer. Minus 10. X not equals C, right? Is it this? Do we need to do that? Is that our bug? Hey, yay. Okay, that worked.
Nice.
Yes. Let's run our test, our proper test. Cargo run. 580. Does that somewhat feel like it was in the right spot?
Yeah, that's similar to what I had.
Cool. Yosh and Sai scene. It is both of us. Submit. Yay! Right answer.
Nice.
Cool. Need a radial spin outward. Actually, my stomach's not feeling super great. I think I might like need to stop here for today.
All right.
Yes.
I hope you feel better soon.
Yeah, thanks. We managed to do part 1, and we have a good understanding of how to do part 2. So yeah, hopefully that was fun for stream.
Yeah.
Thanks everyone.
Thanks everyone.
All right.
I will push my code to GitHub.
Yes.
Once I reload my project.
I'll do the same. Day 9.
Oh, there we go.
Cool. It should be pushed.
Me too, thanks.
All right. Take care, everyone.
Yep. See ya.